Hello, this is Minky for the homework 7, exercise 7. For this question, we are given that the theta is uniformly distributed in from 0 to 2 pi. So here, that is the density function. Density function of theta. Yeah, right. From 0 to 2 pi here. And we know that n1t and n2t are y-sense stationary. So the first question is to find the expected value of zt. So zt equals to this expression, and then we could divide it into two parts. So these two parts are similar, right? So here for the first part, it could, since we know that n1t, n2t, and theta are all independent, so we could write it as the multiplication of two expected value. The first one is n1t's expected value, that is eta 1, and the second value is the expected value of this cosine. Since theta is given here, the density function, so the formula here, that is let's write this as gx fx dx, right? So here we need to multiply this cosine term first, and here fx is just 2 pi, 1 over 2 pi, right? Since it is from theta to 2 pi, right? And the theta. That's how we could write this. And second, we could write a similar one. So the integration from theta to 2 pi for a triangular function is 0. So these two terms plus together is equals to 0. This is the first question, and the second one is it led us to find RZ T1 T2. RZ T1 T2, for this question we could just use the formula here. It equals to the expected value of the T1 times the T2, and here we could get 4 terms here. For the first term and the fourth term, that is first, and that is fourth, they are same, right? They are similar, not totally same. So the E of n1 t1 times n2 t2, same here, they are all independent, so we could write it as the two part of the expected value times together. So the first part is equals to Rn1z, and the second part, there's a multiplication of two cosine function. So here we need to use a formula here, that is cosine alpha times cosine beta equals to cosine alpha plus beta plus cosine alpha minus beta. So here, right, that is the cosine alpha plus beta, and here that is alpha minus beta. So since n1t and n2t are WSS, they are y-sense stationary, so we could let t1 minus t2 equals to tau. So that's why I write tau here. You could see that, right? Yes. And for the last, the fourth term, that is sine alpha. Again, there's r into tau, that is the same as the previous one. I just write the formula of these two cosine function here, sine function. So sine alpha times sine beta equals to 1 over 2 cosine alpha plus beta minus cosine alpha minus beta. Yeah, that is for the fourth term. And for these two cross term, the formula of triangle function is cosine alpha sine beta equals to sine alpha plus beta minus sine alpha minus beta. Yeah. Right? And we know that this N1 T1 is equals to eta 1 and 2 T2 equals to eta 2. Yeah, and for the cross term, we could see that they are the integral for a triangle function from theta to theta to 2 pi. So the cross term are all equals to 0. And for the first and last term, the cosine function, these two cosine function are all equals to 0, right? And here we just plus this 1 r and 1 tau and this r and 2 tau here, plus them together. Here that is minus, so that is positive. And we also have 1 cosine omega c tau here, right? Since from here we could know that this is only depends on tau, right? So we could write it as the function of tau. So based on this, we could know that zt is y since stationary, since it only depends on tau. And for the last question, it led us to find RZ0. RZ0, we just take it back here and let tau equals to 0. Right? Since our how to say that? Rn1, that is the expected value of n1 how to say that? Since tau here, tau is equals to 0, so t1 minus t2 is equals to 0. So that's why I can write here as the square of n1t, right? Basically, if we write this x t plus tau x t equals to r tau, right? We now know that this is WSS and t here, that is tau from this question. That t is equals to 0, so that two terms are same, so I can write that n1 square. And here that is same, that is the expected value of n2t square. And here we have an 1 over 2. So, and this is the another term. So this is for this question. Thank you.